the oscillatory motion is a motion which will occur due to a restoration force. Restoration. For instance, we have the mass spring system. We have any given mass which is attached to a spring, okay? And this spring, has a constant K, this mass has a mass M. And we know that Hooke's law states that the force due to the spring is equal to minus Kx. Minus is negative because it's a restoration force. It means it is going to go against the displacement. It tries to restore the initial position of the spring. So second Newton law states that this minus Kx, this force, is going to be equal to mass times acceleration, being acceleration the second derivative of position due to time. So this is the second derivative of position in time. We can actually build this equation as the second derivative of position due to time plus K over M times X equals 0. This is a differential equation of second order, and I do not expect you to know how to solve it. So the solution to this equation is X equals A, which is the amplitude, the maximum position it can have in X, times the cosine of omega 0 t plus phi. Now, omega 0 is the angular frequency. Given in the mass spring system as the square root of K over. Now I want you to remember as well that frequency is going to be omega 0, which is the angular frequency, over 2p, and that the period is going to be 1 over the frequency, which is in this case 2p over omega 0. And phi is going to be called the phase, and the phase is when the motion in time equals 0 is not in x equals the amplitude. So the meaning of this is when the motion does not start exactly at the amplitude, there is a phase. So a graph of position due to time, if we have time here and we have position x, it's a cosine graph, right? Something like this, where of course we can state this is a 0 position and it will oscillate from amplitude to minus amplitude, and this is an oscillation. If it does not start at the amplitude, then this will be, for instance, shifted, and this will generate the phase. So for instance, the equation for the blue one will be position equals amplitude cosine of omega 0 t, because it starts at time 0 at the amplitude, but for the green one could actually be x a cosine of omega 0 t plus a phase, such that at initial time the position is not the amplitude. Now, of course, if we have this position due to time as a cosine of whatever, then if we want the velocity how do we get the velocity is the derivative of position due to time. Is it okay? So this is going to be minus a sine of omega 0 t plus phi times the omega 0, which is the derivative of the argument of sine. Being the maximum velocity plus minus omega 0 times a, when the sine is maximum at 1 or minus 1. Is it okay? And the acceleration is going to be the second the derivative of velocity due to time, or the second derivative of position, which at the very end will lead to minus omega 0 squared a cosine of omega 0 t plus phi. And this maximum acceleration is given as plus minus omega 0 squared a.